right, so we have one more method here for graphing. And so this is graphing parabolas that are in factored form. All right, so what we've done is we've seen them in vertex form. We've seen them in standard form where we convert to vertex form. And then this is the last one, and this is solving by factoring. So when we have something like this, that it's easy to factor by trial and error, we want to do that. So this is an easy one to factor. And if I factor this, I know my factors of 12 are 3 and 4. So I would have x minus 4 and x plus 3 equals 0. I have this equals, I have to keep the equals. So if I'm going to solve this, then I know that x equals 4 and x equals negative 3. So if I solve this, factor it, solve it, here's what I get. So let's see how this what this looks like when we actually graph the parabola. So step 2 says, use your calculator to graph the function and find the zeros. So I'm going to use my calculator here, and I'm going to graph x squared minus x minus 12, and I'm going to graph that. Okay, now I see I have a parabola. I really don't care about the bottom of the parabola because what I want to know, what it tells us here, is find all the zeros. And remember, the 0 is where we cross the x-axis. So I can go in and I can do second trace and find the zeros and go in and graph this, but I'm just going to count this. So if I look at this, I would go over to negative 3. So x equals negative 3, and I would go 1, 2, 3, 4, and I have x equals 4. So what do we notice here? What we notice is the zeros of the parabola, which are right here, are equal to the zeros that are in our factored form. So what do we notice? We notice that they are the same. So what does that mean? So what that means is when we solve the equation, finding the zeros, so finding the zeros, which what we did when we factored, we said find the solution, is also known as the x-intercepts of the parabola. So we've graphed it, we know what it looks like, but the bottom line is I could have gone over here and I could have said, okay, this is negative 3, this is 4. This is where I'm going to cross my my axis, and I know that this opens up. So I have some graph that's going to look like this. Okay, so I've already got 2 points on my graph that I need. I just need to know what's happening down here in my vertex. How low do I go on my vertex? Okay, so without using your calculator, find the x-intercepts of the following parabolas. So what does this mean? We want to find the factors and solve. So if I factor this guy, I'm going to have x plus 4, x minus 2 is equals 0 because I want to solve. I want finding the x-intercepts I want to solve, and I know there's not a 0 here, so you have to understand what that means. So this tells me x equals negative 4 and x equals 2. Okay, this one is a little bit harder because I'm going to have to actually do trial and error on here. I cannot pull out a GCF. So I'm going to start with my closest factors, 2 and 2, and 3 and 5. So if I have 2x, and 2x, and 5 gives me 10, and 3 gives me 6, I know it's the same sign, and those signs are both negative. And I went through this quick, but we've done a lot of factoring, so you should be able to solve this one now. Maybe not quite that fast, but you should be able to solve this one on your own. And I get x equals 5 over 2, okay? Not a whole number, but that's okay. And x equals 3 over 2. Again, not a whole number. So what is this number? Well, this number is 2.5, and this number is 1.5. And we're going to come back to that in a minute. So these are my fraction solutions, which is how we've always reported this when we did factoring and solutions, but this is what it looks like in terms of a number that I'll put on a number line. Okay, so finding the vertex of the parabola. So we know that we've got these 2 points here. We just need to know how low do we go. Where is my vertex? I don't know that. Where's my vertex? So what happens is the x value, so the x value of the vertex is the middle of the x-intercepts. And I'll show you what that means here in just a second. And then it says find the y-coordinate by substituting x into the equation. All right, so without a calculator, find the vertex of the parabolas above. So that's this one. So here's what I have. I'm gonna graph this first so you can see how this works. So I have 1, 0 at -4, and I have 1, 0 at +2. So step 1, x is the middle of the x-intercepts. Well, here's an x-intercept and here's an x-intercept. So if I have 1, 2, 3, 4, 5, 6, the distance here between this is 6. And if I want to go halfway, half of 6 is 3, so I'm going to go 3 this direction. And I'm going to 3 this direction, 1, 2, 3. And this value here at x equals -1 is the middle. This is the middle of my graph. Now, if this is the middle of my graph, this is my axis of symmetry. So I have my axis of symmetry right here at x equals -1. I'm going to take -1 and plug it back into my equation. So f of -1, the y value when x equals -1 is -1 squared plus 2 times -1 minus 8. So remember, in parentheses, so when this is squared, it's positive. So 1 minus 2 minus 8. And if we want to know what that value is going to be here on my axis. So if I have 1 minus 2 minus 8, that value here is going to be -9. So my vertex happens at -1, -9. So if I go down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is where my vertex is. So my graph is going to look something like that. But this is what I needed. I needed this point, which is right here. All right, let's do this one. Now I know these are fractions, but don't get caught up on that yet. So I have 1. Let me do this. 1, 2, 3, 4, 5. So I have 1, 0 at 1.5. So 1.5 is right here between 1 and 2, and I have 1, 0 at 2.5. So 2.5 is right here between 2 and 3. So if I want to know what is in between, well, in between is just going to be this value of x equals 1. So I go half a step this way and half a step this way, and this is what's in the middle of the two. So even though those were fractions, just look at it on the graph. It makes a lot more sense. So now I take this value of 1 and I plug it in. So f of 1. Remember, I'm plugging it into the original equation. So 4 times 1 squared minus 16 times 1 plus 15. So this gives me 4 minus 16, plus 15. And when I plug that in, I get, hold on, I'm having a brain fart, 3. 4, so this is -12 plus 15, yeah, 3. So this point here, my vertex happens at 1, 3. So I take this value here, and I would have 1, 3, which would be right here. Hold on, I did something wrong. 1. Oh, hold on. Yeah, this is going to be -12. Oh, it would be. What am I doing wrong? Oh, goodness, I'm so sorry. Hold on, I'm going to step back. I made a goof up here. So halfway in between here is this whole value. This whole value number is not 1. This whole value number is 2. This value here is 1. So x equals 2. Sorry. Okay, but hold on. Let me talk about this. So I had this point up here, and I knew that was wrong, and I knew that was wrong because my a value here is positive. So if my a value is positive, it has to open up. Well, if these are my intercepts, that doesn't work because it would go down. So I knew, that's how I knew it was wrong. So I gotta change this too. Sorry, that's what happens when I'm on a video. I'm not gonna redo this though. So what happens when x equals 2? 2 squared minus 16 times 2 plus 15. And because I'm doing so many mistakes today, this is going to be 4 times 4 is 16 minus 32 plus 15. And I'm going to plug that in my calculator today because this is negative 1. So this value here is at 2, negative 1. That makes so much more sense. And I see that it's a super narrow parabola, which makes sense because my a value here is 4. Okay? All right, let's flip it over. All right, so a little practice on this. So it says sketch the graph in factored form. So first thing that I have to do is factor this quadratic. So I see that I have x minus 5 and x minus 3. Right? This is an easy one to factor. My factors here are 5 and 3. I add those up, I get negative 8. So my zeros happen at x equals positive 3 and 5. So I can go down here on my graph, and I'm going to plug those in. So 1, 2, 3, 4, 5. Those are my two zeros. So if this is 3 and this is 5, then my vertex happens right here in the middle. That axis of symmetry happens right there in the middle. So I know that that value, the x value of that, has to be 4. And so when I plug the 4 in here, I get 16 minus 32 plus 15. So 4 squared is 16. Negative 8 times 4 is negative 32. And then the plus is 15 that's on the end. And so if I add this up, I get negative 1. So my vertex happens here at 4, negative 1, which is this point right here. And my parabola would look like this. Okay, let's do this one. Hopefully what you see here is this is a difference of squares. So 3x plus 2, 3x minus 2. So my zeros happen at excuse me. Goodness, hold on, let me go get some water. Okay, much better. Okay, so my zeros happen at negative 2/3 and positive 2/3, which those are yucky numbers to graph, but we can still graph those. We know that that's almost 1 and almost negative 1. So super narrow, right? Which makes sense because my a value is 9, and 9 tells me that this is going to be very narrow or a skinny graph. So what is halfway between these? Well, this is easy. What's halfway between these is 0. So when x equals 0 right here. So if I plug 0 in, I get 0 minus 4, which is just negative 4. All right, I plug 0 in here. 0 times 9 is 0 minus 4. So my vertex happens, 1, 2, 3, 4, clear down here, and I get this really skinny graph that looks like that. Okay, 2 more. So what are my zeros? I have to factor this. I see it's negative, so my signs are going to be different. So x minus 6, sorry, not 6, 4. X minus 4, x plus 2. Okay, negative 4 plus 2 is negative 2. So my zeros happen at negative 2, and x equals 4. So at negative 2, I have a 0 right here. 1, 2, 3, 4, I have a 0 right here. So now I have to figure out what's in the middle. So if I go 3 this direction and I go 3 this direction, this is what's in the middle. And then once I draw this axis of symmetry, I can go back and look and say 1, 2, 3, 1, 2, 3. So I know the vertex happens when x equals 1. So I plug 1 back in, and I have 1 minus 2 minus 8. So that value is negative 1 minus 8, which is negative 9. So this point here, 1, 2, 3, 4, 5, 6, 7, 8, 9, happens right here. That's what we look like. And this is a little pointy. This is kind of looking like a V. I didn't do a very good job on that one. Okay, one more, last one. So factors closest together is 2 and 2. Only factors here are 7 and 1. So I see 14 and 16. So I know this is going to work. So 2x plus 7 and 2x plus 1. I can test it. 14 plus 2 is 16, except for these need to be negative. So my zeros happen at 1/2 and 7/2, right? 1 over 2 and 7 over 2. Now what is 7 over 2? 7 over 2 is the same as 3.5. So don't get jammed up on that. Okay, so I have 1 0 at 1/2, which is right here, and I have 1 0 at 3.5. So 1, 2, 3.5, which is right here. So what is in the middle of this? So if I go half on both of these and then I go in, my axis of symmetry happens right here, and that's at x equals 2. So I plug this value of 2 back in, so 4 times 2 squared minus 16 times 2 plus 7. Oh, we've seen these numbers already, so we know that this is negative 9. Right? So 16 minus 32 plus 7 is negative 16 plus 7. Yeah, negative 9. Okay, so my point here is 2, negative 9, which is going to be clear down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's what I have. Again, super narrow, which makes sense because this value here is 4. Okay, thanks for putting up with my mistakes and my coughing today. I'll see you in class.